You might have heard something on the uranium enrichment program in Iran and the centrifuges. So let me just put some of that in context in case you were wondering what's going on. So uranium, one of the elements on the famed periodic table, it has 92 protons in it. And the number of protons in an element defines the element. Uranium is traditionally considered the heaviest natural element. We look around the universe, do we see anything heavier than that? No, not really. We, however, are not content with what nature gives us. We want more. So in particle accelerators, we bombard the nuclei of elements and we can make heavier elements than uranium. And we've done so. Last I checked, we're up to 118. That's 26 more elements than the universe gave us. So frankly, I think that's badass for humans with our primate brain, being able to come up with that kind of advance on something birthed in the universe. I've seen maps of the world, flat map of the world, and airlines show you their routes between cities.
Correct.
You ever notice it always makes an arc?
Yeah, it's always a curve.
Why don't they make a straight line?
Well,
shortest distance between 2 points on a flat surface.
Straight line?
A straight line.
Of course.
But if that surface is curved, it's not immediately obvious what path you should take to minimize the distance traveled. Okay? That exact path is called a great circle.
That's a great circle?
Yes, what we call it, where we're keeping an eye on the sun. Like, what are you doing today? Boom, explosion, but that went off in this direction. Boom, explosion, that went this way. Boom, headed straight towards us. You can calculate how fast are these particles moving and how long will it take before it slams into Earth. These are charged particles, politely known as the solar wind. This is a swarm of charged particles headed towards us. We have a liquid iron core. It's called a dynamo phenomenon. When you have a liquid core, the churning of that liquid electrically conducting material called iron that generates a magnetic field. The negative and positive charges coming from the sun upon seeing Earth's magnetic field split, one to each pole of the Earth. These particles slam into the molecules of Earth's atmosphere, primarily the nitrogen and oxygen molecules, the two dominant species of gas in our atmosphere. They slam into them, kick them to higher energy level. Now, these asteroids already live inside of our orbit. Most asteroids are in the asteroid belt, including my own. It's 13123 Tyson. By the way, when I was told they were going to name an asteroid after me, I double checked. I said, does it cross Earth's orbit? Because you don't want that asteroid aiming at Earth. Asteroid Tyson will take out, you don't want that asteroid. No risk of asteroid Tyson ending civilization. So you might ask, how big are these asteroids? If they're tiny and one encounters Earth, it would just burn up in the atmosphere. Above a certain size, it'll sort of fall but not hurt anybody. Most of Earth is uninhabited. How big are they? Well, maybe the size of a stadium. Yeah, that's not so uncommon a size of asteroid. In fact, the smaller the asteroid, the more of that size there are out there. So the one we should keep an eye on are those that are big enough to destroy a city. The clickbait version of that is city killers, all right? Not city slickers, city killers. I'm not worried only because most of Earth's surface is water. Most of Earth's surface that's land is not city. It's like deserted, unoccupied, and even where it does have people, it's rural or suburbs. Cities are such a vanishingly small fraction of the total area of the Earth. Statistically, I'm sitting just fine as an urban dweller. So, most asteroids, including mine, orbit in the asteroid belt, very distant from harm's way. But the moment an asteroid ends up with a wayward orbit, and there are many ways that can happen, and many asteroids have such orbits, it crosses the orbit of Earth. It's now susceptible to be captured by Venus and have it hang out there. But also, this is kind of a repository where if another asteroid comes by and jiggles one loose, we're not that far from Venus. Venus, of all planets, is the closest planet to us in the solar system. So if it's got asteroids up front and asteroids in tow, and they're hiding in plain sight in the glare of the sun, we're at risk of one of those asteroids getting dislodged from its orbit and having us in its sights. And we wouldn't even know it had occurred.
Nomer. From what I recall, we don't actually have any evidence the Big Bang started with an explosion like a supernova or a black hole merger.
Yeah, so first of all, the Big Bang was a name given to this idea that the universe started in this one primordial explosion. It was given pejoratively to this idea by proponents of what at the time was known as the steady state theory, hypothesis of the universe. One where the universe always was and always will be, even though it's expanding, it's always been expanding. And matter is spontaneously created in the vacuum to fill in for where space is getting thinner. So that you'd always see a universe that looked about the same. This is called the steady state hypothesis. You could get that out of Einstein's equations of gravity. That was allowed. But another solution was one where we're either collapsing or where we're expanding. All three solutions were allowed. The one with the Big Bang itself, it was an equal competitor to the steady state theory for decades until we finally got some evidence to support the Big Bang. And that was the famous cosmic microwave background. This is a leftover signature from an explosion that started in one hot primeval fireball.
13.8 billion years ago.
Thank you, sir.
Okay.
So it was given as a funny pejorative name, but it stuck, and
Right.
if it fits, it fits. Now it's not clear how much noise it would have made, because just the expansion of space itself is not, that's not associated with noise. And space is vacuum anyway, and noise doesn't propagate.
Laws and theories and what used to be called
You
laws.
remember
we
that?
call
Thank
theory.
you for that's a subtle point. In the old days, we'd come up with an understanding of the universe. A new law has been discovered. That's a very exciting time in science when that happens. And then you learn later on that with better instruments and more tools and deeper thinkers, that what you came up with as a law was a smaller subset of a larger understanding. So you shouldn't call it a law.
Right.
But it works.
Right.
So we just use the word theory for everything that works now.
Right. Well,
And if you just have an idea that hasn't been tested, we call it hypothesis. Paul's hypothesis.
Right. Well,
Stars are born per year. How many die? Well, it's about 100 a year in our galaxy. We've had like a stable amount for the last several billion years. And the way you calculate that is we have about 100 billion stars in the galaxy, and the universe is 10 or so billion years old. It's about 100 a year, between 10 and 100 a year. So you got it. Next up, for him to just say, let's go to Mars because it's the next thing to do, what does that venture capitalist meeting look like? So, Elon, what do you want to do? I want to go to Mars. How much will it cost? $1 trillion. Is it safe? No, people will probably die. What's the return on the investment? Nothing. That's a 5-minute meeting, and it doesn't happen. So
We agree. I'm not for going to Mars.
okay, wait. I got nothing against Mars. Elon wants to terraform Mars, and if you do that, you could then just walk off a spaceship and breathe the air. But if that's Earth Plan B, what did you do to Earth that now you got to go to Mars? If you messed up Earth, but you're good enough to turn Mars into Earth, then you can turn Earth back into Earth and never have to go where
Earth stop rotating for a second.
Oh, yeah, that would be disastrous. Disastrous, because right now, here in New York, you can calculate at our latitude, we are all moving with the Earth at 800 miles an hour, due east, because Earth is rotating. If you stopped Earth and you weren't seatbelt buckled to the Earth, you would fall over and roll 800 miles an hour due east. It would kill everyone on Earth. People would be flying out of windows, and that would just be a bad day on Earth. I'm just saying. Now, if somehow we all slowed down, so anything not bolted to the Earth would fly due east, 800 miles an hour. That's what happens to you in a car if you hit a brick wall and you're not wearing a seatbelt. You keep going. That's why you get hurt in those kinds of accidents. But if somehow we all slowed down with the Earth, then okay, that's fine. I mean, people think, well, somehow we'll be weightless or we'll lose our atmosphere.